Yeah, on behalf of Kelsey and myself, I'm thrilled to present what we think might be the first public presentation of an Artemis II science plan. So, it's exciting times. If we go to the next slide, you'll recall, starting with Jim Free's presentation, having moved on from the successes of Artemis One, we turn our sights now to the opportunities presented by Artemis Two. We saw public interest in Artemis One was pretty profound. I think we were all taken aback at the quality of the images that came back from that mission. And in the aftermath of Artemis One, we've worked closely with the NASA public affairs offices to craft how we can tell the story better about lunar science and lunar exploration with Artemis Two. So Artemis One was really proving ground in many ways, but also in what we can build on in terms of lunar science observations and getting the public, getting the world excited about what we're doing at the moon with Artemis. Um, we learned multiple lessons about getting data back from the spacecraft in real time and the infrastructure that we'll need on the ground to do this even better with Artemis 2 and subsequent images. The video that you see at right there is, of course, one of my favorite, where we get glimpses, real-time glimpses of the far side of the moon, including South Pole Aitken Base, and it was a really stunning few hours. Gosh, it feels like a lifetime ago at this point, but just a few months ago that we were able to enjoy this ride. But now we turn with our eyes to the future in Artemis 2. Next slide, please, Sam. So this cartoon has probably been seen multiple times. I want to walk through it a little bit. Artemis 2 will be a just under 2-week mission, sending 4 crew members out beyond the moon for the first time since 1972. But there are several lead up steps that are important in getting astronauts to the lunar vicinity, including the first time astronauts will leave low Earth orbit since 1972. After launch, they'll do one orbit of the Earth before going into a highly elliptical orbit. This will, allow the spacecraft to be tested in ways that we've never been able to test it before. Certainly, crew members are very excited with the operational phase of this portion of the mission. After that second orbit, that long looping orbit, they will come back, and for the first time since December 1972, the crew will be given the command to do a translunar injection burn. That will send them on a long looping course out beyond the far side of the moon, several thousand kilometers beyond the far side of the moon. This is going to be the portion of the mission that both Kelsey and I are most intimately involved with in terms of getting plans together for crew observations. And we'll walk through that in a few moments. Of course, the most critical component is the free return trajectory that gets them back to the Earth for splashdown off of San Diego, again, about 10 days after the launch. So let's go on to the next slide. So, we don't know some of the details about Artemis 2. So, in terms of planning for Artemis 2, what do we know? Well, we know that there's going to be these 4 crew members that are going to fly on this mission, and they'll have an opportunity to observe the full far side of the moon. We don't know the exact trajectory, we don't know the timing yet, but we are beginning to integrate with the mission operations team and have made excellent inroads with the Flight Operations Division at JSC to start planning an observation campaign. As Kelsey will discuss later on in this presentation, this will prove to be a test ground for Artemis 3 and beyond for orbital observations, operations, and how we integrate into crewed missions. Let's go to the next slide, please. So we got a preliminary set of potential launch opportunities, about 200. This is a kind of a flip book of possible views that the Artemis 2 crew would have at close approach over the far side of the moon. You can see several opportunities include nearly full disk illuminated far side spheres and through various far side phases of the moon. Each of these give us an opportunity to start mentally planning an observation campaign for the 4 crew members during their close approach. Um, we have no insight at this point over exactly what the date or time will be of this close approach, but as soon as we get that information, we will of course develop a more rigorous and implementable observation strategy for the Artemis 2 crew. I'll let this video play because it's quite stunning. I love it, and it's also a good reminder that for the first time we'll have the opportunity potentially for whole disk far side views, and particularly under high illumination conditions, there are a number of albedo features that we could, of course, observe, and some areas of the far side that were never observed by Apollo crews because they were, of course, in shadow. All right, let's go on to the next slide, please. So the basis of our science plan at present are crew observations. It's important to note that 3 of the 4 crew members that are flying on this mission have ISS observation experience, and we're going to leverage that. We anticipate, depending on the illumination conditions, we'll either, of course, train astronauts on observing for albedo differences. Obviously, we can see the extensive ray systems, bright lunar features. Of course, color differences are going to be a pretty fundamental question that we're going to be asking them to observe. In addition to just allowing the entirety of the world to ride along as they fly over the far side of the moon. And again, it's been a long time since we've been able to say that. Um, but until we get that specific observation window and when these observations occur, we can't come up with a very detailed observation plan. But Kelsey and I are in the beginning stages of identifying kind of a notional set of observation plans for the crew members. All right, let's go to the next slide, please. And here I'll pass off to Kelsey for the science and integration plan for the mission.
Thanks, Noah. Yeah, so as Noah alluded to earlier, science is really tightly integrated into several phases of this mission, including the plan phase, the train phase, and the fly phase. In the plan phase, Noah already talked a lot about it, but we will have science input into the crewed activities that occur during the lunar pass. Noah gave some really great examples of what we're going to be asking the crew to look for and describe. And we're also planning to work in some science synthesis time following the pass so that they can really digest in the context of the science questions we're asking them to think about, they can digest the observations they just made. Cindy's going to talk a lot more about training, so I encourage you to stick around for the very last talk today. But briefly, we did just have about 48 hours of lunar fundamentals training time spent with the Artemis II crew just a couple weeks ago. Cindy can go into a lot more details there, and we do expect some additional training opportunities prior to flight once we understand what that exact trajectory and the resulting detailed observations are that we're going to be asking them to address. There will also likely be training implications for the scientists who will be supporting during real-time operations, as well as other critical flight control team members on the ground who are expected to support the lunar flyby and the resulting crew observations that we'll be building into the timeline. And then during the actual fly, in the mission execute phase, we will have science integrated into the flight control team. I think Sarah alluded to this earlier, but not only will Artemis II be, enabling the crew to make some really, really compelling observations, but we'll also be able to use the mission as sort of a test and proving ground for Artemis III+ missions, especially from the perspective of integrating science into the flight control team and into mission control and testing out what that's going to look like. A note from Kevin Sato as well that from a BPS perspective, space biology science payload accommodations is currently being reviewed by Orion. So hopefully we'll have more information about that moving forward. Next chart, please. Okay, so I just said it, but of course Artemis II is going to be compelling in its own right for some of the observations that Noah introduced earlier, but it'll also be really vital in preparing us for the future of Artemis and science integration into the execution, and the planning of Artemis missions. This is going to be critical from the perspective of integrating science into the mission planning process and into the mission objectives prioritization process. And as Noah said, that process from our point of view is just beginning from a science integration into Artemis II process, but we plan to really learn a lot from this mission that will enable us to move forward with integrating science into Artemis III and beyond. Noah touched on this earlier, but we also plan to really use Artemis II to understand imagery acquisition and the downlink procedures to get those images throughout the lifetime of the mission and the resulting infrastructure that we need to support that imagery acquisition and downlink. It'll also allow us to integrate discovery-based real-time lunar science into mission execution and the flight operations and mission control structure that has to exist to support that. From a structure perspective, how do we as the science team get inputs to the crew efficiently through the flight control team? And from an infrastructure perspective, we're developing the mission control infrastructure that the science team will use to integrate into this entire big picture. Next chart, please. And just to wrap up, for the first time since 1972, we are sending humans to the moon. Artemis 2 will afford us some absolutely spectacular views of the far side. We have 4 spectacular crew members who are ready and excited to provide observations to us as lunar scientists. They've already received lunar science training, and even more is anticipated. And Artemis 2 is going to be an incredibly exciting proving ground to test CONOPS for science integration into the future Artemis mission. So we're really excited to the moon, and we can't wait to see what happens with Artemis II crew when they get their eyes on the surface of the moon. Thanks.